Section 4.3, Part 2. The first thing is cofunctions of complementary angles are always equal. These must be memorized. Okay. We will be using these when we want to simplify certain angles and we want to find certain angles. Now, fundamental trig identities. These also must be memorized. Okay. We already know the first six, the reciprocal identities. The sine of theta equals 1 over cosecant, cosine equals 1 over secant, tan equals 1 over cotangent. So cosecant equals 1 over sine, secant equals 1 over cosine, and cotangent equals 1 over tangent. Now the quotient identities are new. Tangent is equal to sine over cosine. So therefore, cotangent equals cosine over sine. And then the Pythagorean identities also must be memorized. Sine squared plus cosine squared equals 1. 1 plus tan squared equals secant squared. And 1 plus cotangent squared equals cosecant squared. And we will see how we can use these. Example 4, let theta be an acute angle such that sine of theta equals 0.6. Find the values of cosine of theta and tangent of theta using your trig identities. Okay, we're going to do it two ways. First, we're going to use our trig identities. This is the first way we're going to do it. Then we're going to do the same problem again using a triangle. All right, so first to find cosine, you need to figure out the relationship between sine and cosine. And that relationship is sine squared of theta plus cosine squared of theta equals 1. So that means 0.6 squared plus cosine squared of theta equals 1. So cosine squared of theta equals 1 minus 0.36. So that means that the cosine squared of theta equals 0.64. So cosine of theta equals 0.8. Now for B, you need to find the tangent of theta. Now we can use the relationship that the tangent of theta equals sine of theta over cosine of theta. So sine of theta is 0.6, cosine of theta is 0.8. That's the same thing as 6 over 8, which is the same thing as 3/4 or 0.75. So the tangent of theta is equal to 0.75. Now we're going to do the same problem, but this time drawing the triangle. So what I can do is if I draw a simple right triangle, now put your theta in one of the acute angles. Now I know that the sine of theta is equal to 0.6, which is equal to 6/10, which is equal to 3/5. So that means 3 is my opposite and 5 is my hypotenuse. So that means my side opposite my angle is 3, the hypotenuse is 5, which leaves their third side to be 4 because it's a 3, 4, 5 right triangle. So then from there we can just use our trig ratios, that the cosine of theta is adjacent over hypotenuse, which is where the 0.8 comes from, and tangent of theta is opposite over adjacent, which is 0.75. Example 5, let theta be an acute angle And I know that the tangent of theta is equal to 3. I need to find the cotangent and the secant. Well, first off, the cotangent of theta is equal to 1 over the tangent of theta, so that's going to equal 1 over 3. And B, secant squared of theta equals 1 plus tangent squared of theta. So I have secant squared of theta equals 1 plus 3 squared. So secant squared of theta equals 10. So secant of theta equals the square root of 10. Now, when solving right triangles, when you are given one side of a right triangle and one of the acute angles, then you might be asked to find one of the other sides. Or you can be given two sides and you have to find the acute angle. When you're using this, you're going to use your calculator and use the sine to the -1 with something, the cosine to the -1, or the tangent to the -1. These three find angles. Okay. A surveyor is standing 115 feet from the base of the Washington Monument. The surveyor measures the angle of elevation to the top of the monument as 78.3. How tall is the Washington Monument? Okay, so I know the angle of elevation and I know how far I'm standing away from that. So I need to figure out the height. So I will use the tangent. So I have the tangent of 78.3 equals opposite over adjacent. Now rearranging so that y is by itself, I get that y is equal to the tangent of 78.3. Now at this point you will have to use your calculator because nobody knows what the tangent of 78.3 is. So typing that in, I get that y is equal to 555.3 feet. It's going to have the same units as how far the man is from the Washington Monument. A historic lighthouse is 200 yards from a bike path along the edge of a lake. A walkway to the lighthouse is 400 yards long. Find the acute angle between the bike path and the walkway. Okay, so this time I'm looking for the angle and I have this side opposite it and the hypotenuse. So I'm going to do that. It's the sine of theta equals opposite over hypotenuse, which reduces to that the sine of theta is 1/2. Now, since this is one that needs to be memorized, okay, this is one that needs to be memorized. We do not have to use the calculator. We know that the angle is equal to 30 degrees. But in case it wasn't one that we'd have to have memorized, then all we would do would be sine to the -1 of 1/2 in my calculator, and that would spit out 30. And the last example, find the length C of the skateboard ramp shown. So I have this side opposite it and I have the angle, so I'm looking for the hypotenuse. So I will be using sine again. So it's the sine of 18.4 equals opposite over hypotenuse. Now solving for c, I get that c equals 4 over the sine of 18.4. So again, you have to rely on your calculator. So I get that c is equal to 12.67 feet. Now you must memorize all of the previous stuff from part 1 video and part 2 video. Those Pythagorean identities, the quotient identities, the cofunctions, sine, cosine, tangent for 30, 45, and 60 degrees. All of that must be memorized.